Ooh. Intense.
That was very intense. I'm really hoping that I'll do good again on the first part, but it's, yeah, that's what I'm counting on.
Okay, let me talk about what I've written up here. You probably want to write these steps on your cheat sheet. This is the steps to doing the hypothesis. First thing, we want to write out the hypotheses. The null hypothesis, H naught, is always P equals whatever value I believe P equals. It'll have to be given somewhere in the question. The alternative has three different choices. P is greater than that belief, P is less than that belief, or if I want to consider both of those possibilities, then simply P does not equal. Not equals to means it's either less than or greater than. To find how far, so we're going to have a P hat and we're going to have a value of P. And if they agree, that's great. There's no need for a hypothesis test. So clearly the ones I give you are not going to agree. Here's P hat. Remember, there's two possibilities, two explanations for why P and P hat are not the same. One is just coincidence. P is the true value in the population, but I got a P hat that's different from that just because P hat came from a random sample. And because it's random, I got something a little different from what I expected. That's one possibility. The other possibility is that I'm just wrong about P. So the discrepancy that I observe between P and P hat doesn't actually exist. It only exists in my mind because I was wrong about P. And those are the only two possibilities, coincidence or not coincidence, meaning I was wrong. We compute the z-score to find the p-value. The p-value is the probability of coincidence. That's why if the p-value is really low, below 5%, I say, well, it was not a coincidence. I must have just been wrong about P. We call that rejecting the null hypothesis, rejecting my initial belief about P's value. If my p-value is above 5%, above 0.05, then I'm going to allow that the discrepancy between P and P hat could have just been a coincidence. And I'm going to say then I failed to reject the null hypothesis. P could still be what I initially thought it was. We find that p-value, so I gave this table in last class, you may want to have this for your cheat sheet. If I correctly chose the greater than alternative, this one here, then I should get a positive z-score. If I don't, then I've made a mistake. And then the p-value is just the probability that z is above whatever value I got for that z-score. If I correctly chose the less than alternative, and I choose the alternative for my hypotheses, remember, based on the wording of the question. Words like has increased, has decreased, or simply has changed or is different from. If I correctly chose the less than, I should get a negative z-score, or I've made a mistake. And then the p-value is the probability that z is less than that z-score. If I chose the not equal to, because the wording of the question suggested that, I could get a positive or negative z-score, so there's no double check in that sense. And the p-value, well, I have to consider both. The p-value is the probability that z is less than the negative of whatever z-score I got, plus the probability that z is greater than the positive of that z-score, whatever it was. So follow these steps, try the two hypothesis tests I just passed out, and we'll go over them in about 5 minutes. Yes? Sorry? Probability that z is less than negative of the absolute value of z, which is just saying the negative of the z-score. So if you got a negative z, just leave it as is. If you got a positive, then turn it into a negative. And then over here, you use the positive. Sorry?
Is that a subtraction sign?
No, this is plus. This plus this. You mean this here?
Yeah.
That's just a negative. That just means negative z. The probability that z is less than negative of whatever value I got for z-score. So let's say my z-score was the negative of the absolute value. So if I got -2, this would be -2, and this would be +2. If my z-score were +2, this would still be -2, and this would still be +2.